Good afternoon. So I am here to explain to you how to calculate the density of the air relative to its temperature. So first, I want to introduce this to you, the table that you can find on page 7 of your module. So I am giving emphasis to temperature and density only. Okay, makikita natin dyan that the temperature value has its corresponding density. Yeah. Okay. So because in solving problem that I put in the SQA, you need to refer to this table to get the value of the density. So makikita natin na yan dito sa part na ito that the relationship of density is inversely proportional to temperature. So that means as the temperature increases, the density decreases. Makikita niyo yung value niya, pa-decrease yung density, di ba? Well, makikita niyo yung, yung temperature, pa-increase siya from negative 40 degrees Celsius sa 1000 degrees Celsius, the density is 0.2772 na lang. So the relationship is inversely proportional. Again, as temperature increases, the density decreases. I hope that's clear. Alright, so here's the problem about density relative to the temperature. So the density of air is 0.946 kilogram per cubic meter at 100 degrees Celsius. So that means if we're going to go back to the table on page 7, the value of the air at 100 degrees Celsius is 0.946 kilogram per cubic meter, the value of the density. So here also given yung volume niya. The volume of the air is 10 cubic meter. So you have to calculate for the mass of the air. So it's just like what is the mass of the air at 100 degrees Celsius with a volume of 10 cubic meter. So the formula for mass, I hope that you still remember the formula for the density. Ito yung formula ng mass. Volume times density, derived from the formula of the density, which is mass over volume. Okay, let's substitute the value of the volume. Here is 10 cubic meter. Ito yung 10 cubic meter natin. And then the density is 0.946 kilogram per cubic meter. Okay, let's cancel out the unit so that the unit for mass will remain. Okay, if we're going to do the calculation, that 10 times 0.946 kilogram, we will arrive to this value. Okay, I have also included there the specification of the variables for the formula. M stands for mass, the unit is kilogram. V is for volume, the unit is cubic meter. And the rho sign is density, which is a unit of kilogram per cubic meter. Okay. So let's proceed here to your SAQ. So the number one problem is just like the problem, the example problem, the sample problem, right? So we are looking for the mass, wherein volume is given, but here the density is not written in the problem. So you are going to go back to page 7 to get the density of the air at 40 degrees Celsius. Alright, so and then just proceed with the formula. So formula is mass equals volume times density. Alright, so you already have the volume. Just get the density from the table at 40 degrees Celsius, and then you are good to go. So, okay, for the number 2 SQA, here, you are going to look for the volume. The mass of the air is 100 kilogram, and the density, you're going to refer to the table, kunin yung value ng density at negative 40 degrees Celsius. And you can still remember The value for volume is mass divided by density. Okay, so binigay ko na yung formula. Alright, so I hope that you will be able to get the answers, the correct answer for this part. Okay, that's all for today.